All right, so it's number 5. Let's go through and we'll do all of it, okay? So we'll do in case you're having issues with any of the domain stuff, you can see another example of that. In case you have any issues with any of the 4 operations that we do, you can see how we should address that in these questions. So let's find f plus g, f minus g, f times g, and f divided by g. When we go f plus g, so let's just first find the domains, okay? Because that's going to be needed in all of these parts. So as long as we find the domain of f of g, sorry, f of x. So f of x, its domain, okay? This is polynomial, correct? Okay, so it's x squared plus x. That is actually, if you think about it, that f of x is actually another combination of a function that was x squared and another function that was x. That kind of makes sense? But when we add together, because x squared had a domain of all real numbers, and because x has a domain of all real numbers, x squared plus x should have a domain of all real numbers. Okay. G of x, same idea. You know, if we said x squared right here had a domain of all real numbers, then it better have still the domain of all real numbers right there. So its domain is all real numbers. So when I start adding these, subtracting these, multiplying these, the domains of these new functions that we create are the overlap, or the intersection of those two domains. Well, if I have the real number line overlap the real number line, doesn't that just give me the real number line? Okay. So the domains for this one should be relatively simple until we get to that. Okay, and we got to think a little bit about that. But f plus g, so f plus g of x is going to be, that up a little bit. It's going to be that function plus that function. And in this case, the order doesn't matter. But if I add those together, don't I get like terms? Don't we get 2x squared plus x? Okay. And then the domain then is again all real numbers. Okay, now they're asking you to put it in interval notation, so negative infinity, positive infinity for that domain. But now f minus g, just be careful here. You have to do the correct order. Okay, so f is x squared plus x. All right. Now you're going to subtract g. So minus g, which is x squared. Now, the only thing you got to be careful with here is that when you subtract the g function, you have to be careful of whether you're subtracting a quantity or not. Okay? If you're missing these because of that, it's something to always pay attention to. So f minus g doesn't do this. So we'll do that. I know it doesn't ask for g minus f, but we'll do that here in a moment. But when these get subtracted, don't the x squareds cancel out? These will be just x. So f minus g of x is just x. The domain, again, is all real numbers. Okay. But if I were to flip it, and like I said, they don't ask this, but if I were to flip it and go g minus f of x, now g is x squared minus now f. Well, f is a quantity, right? So I need to subtract the entire thing. All right, so I see some people doing this. Just x squared plus x. Well, that's only subtracting x squared, right? You need to subtract x squared plus x. You need to subtract both those things. So if I knew, and I think about what's happening here is we're finding rules for y values. If I knew that x was 2 here, I would get, x being 2 there, I would get 4 plus 2, right? Well, if I just write it this way, I subtract 4, and then I add 2. But I really want to subtract the total of 6, right? So I need to make sure that I realize that this is a quantity. You put parentheses around it, and then it becomes x squared minus x and now you get the result of the opposite of x, domain, still all real numbers. All right? So if you're missing that might be an issue. Okay? F times g. F times g of x squared plus x. Okay, and I'm fairly certain they probably accept that in that way. If you want to expand that, x to the fourth plus x cubed is doable. But we find out eventually though that this format here, when we want to start graphing these things, that format there, x squared times x squared plus x, is actually kind of a better format to graph that thing. And really factoring out x here and getting x cubed times x plus 1 will actually be a little bit better than what we currently have. But again, I think it'll accept either one of those. And then domain again, all real numbers. Okay, the domain of all of these things, in contrast, or I guess with the exception of the division, all these domains are the same as the first domain that you found with f plus g. Now if I do f, what is that? F divided by g? F divided by g divided by g of x. Okay, so f was what? X squared plus x, and g is x squared. Okay. Now, can I cancel stuff there? This is what some people want to do all the time. Can I cancel the x squared and the x squared? Some people shaking their heads no. Some people maybe not knowing. Think about it this way. If x is a number, right? Okay. Plug that number in. Let's say x is 3. Okay. So if I plug 3 in here, what do I get? 9. Plus then 3, right? All over 9, correct? Well, that gives you 12. We know that gives you 12 over 9, right? That gave you 12 over 9. Okay. Is that equivalent? We know it should be 12 over 9. But is that equivalent to doing that? Canceling those 9s out and you left with 3. 12 over 9 is 73. No. Okay. So putting in actual values for x might help you realize, maybe if you forget an algebraic rule, might help you realize that no, you cannot cancel those things. Okay. Can I do this though? Can I take an x out of the top and get x plus 1? And now on the bottom I have x squared. And now cancel that x with one of these x's, leaving me x plus 1 over x. Does that kind of make sense? That's legal because when I do add the 9 and the 3 together, and I get 12 over 9, is there a common factor that will divide 12 and divide 9? Yeah, there's a 3 in both those, right? Okay. That 3 that we're factoring out is the 3 that we saw when we canceled these two things arbitrarily. Okay. Because if x is 4, there'll be a 4 then that can cancel out on the top and bottom. If x is 5, there'll be a 5 that can cancel out on the top and bottom. All right. So that's the simplified version. If they want that, I'm not sure. I'm assuming that you could probably put that in, and it'll probably accept it at this point in the course. However, they want to know what the domain of this is. Okay, and when I want the domain, we're going to say it's still the intersection. Okay, it's still all real numbers. However, when I look at the way I wrote this one, before I do any cancellation, okay, I want to talk about where the bottom function is equal to 0. So I'm looking at x squared. Where does that equal 0? X squared equals 0 where? X being 0. Okay. So what we say here is that x cannot be 0. Okay. We want to make sure, if you remember back to the PowerPoint with the introduction to this stuff, we had that set of rules for the domains where, and the domain said, for f plus g minus g, or f minus g, f times g, and any kind of commutative property that may or may not exist with those properties, the domains are the intersection. But when you got to division, it said the domains are the intersection. However, you also have to exclude places where the g of x, the bottom function, is equal to 0. Okay? So we need to take that bottom function x squared, see where it's equal to 0. Okay? In this case, it is equal to 0 at x being 0. So that number needs to be excluded from all real numbers. Okay? So a couple ways of writing that. Maybe we're going to be lazy. We say that all real numbers except 0. But in terms of interval notation, because web science not going to accept that, we go negative infinity up to 0, union 0 to positive infinity. And that would provide me that domain. Okay. Now it's a little bit different. I know they don't ask this, but they might on a test or one of those short quizzes I give you. If I give you g of f of x, okay. Now we flip it, right? Okay, so f of g of x and g of f of x should be reciprocals of one another. So I should end up with x squared over x squared plus x, right? Does that make sense? Okay. And we can simplify that stuff, and if I take the reciprocal of this thing here, okay, well, that's still the same as that, right? Take the reciprocal of that one, x over x plus 1. So this will simplify to x over x plus 1. But again, the main task here is to figure out what the domain is. Domain, again, is all real numbers. Okay, so negative infinity, positive infinity. But now, the bottom function is this f. So now we have to see, where does x squared plus x equal 0? Okay, and that is something we have to factor. So hopefully you realize that as you're doing new types of problems, new concepts, a lot of times you got to look and use old concepts to help you out. Okay, so in order to find a domain and deal with this combined function, we have to factor. Should be something like that. So in this case, x equals 0, x plus 1 equals 0, and really what we're looking for when we're done, we're going to say x cannot be those numbers. So x cannot be 0, and x cannot be negative 1. Those things have to be excluded. So now, when we graph this, the domain is going to be all real numbers, so negative infinity up to infinity, but we're going to kick out these numbers. Negative 1 is the one that we see first in the number line. Okay, in regards to chronological order, negative 1 shows up first, kick that out. And then we go from negative 1 to 0. We'll kick 0 out. And then we've got that function, or that domain for that function. And if you think about it, if we graph this, let's take a look at the graph. Because the graph should verify these concepts here. So if I see if we can load GeoGebra here. X squared and come on, x squared plus x. Okay, so we have what was it, f of x divided by g of x. If we graph that, let's see here, remove these. Okay, so now I'm going to put the line x equals negative 1 in here. Okay, and you see basically a vertical asymptote there, right? So what that tells us is that, as long as I scroll up, whatever number I want to scroll up to, I can zoom in, and there's going to be a gap between the black line of x equals negative 1 and the curve x squared divided by x squared plus x. Now I look over at the other situation, the other place that we thought we had a problem was x equals 0, right? Well, it looks like it's graphed at x equals 0, okay? And I was messing around with this yesterday. GeoGebra sometimes has an issue with this, but if I click on that, I should be able to check out some points here. I'll plug in 0 and see what it gives me back for an x value. Good, it does give me that question mark. So there's really not a point plotted there. If we were to look at this graphically, even though, because the system doesn't have an ability to put an open dot right there. Does that make sense? And that's where people might get confused sometimes with, I graph it and I see that the domain obviously can't be that negative 1, but then it looks like there is a domain value at 0. Okay? It's because the computer doesn't have the ability of putting that open dot there. There are other, there's websites out there, there's other programs out there that will put an open dot there, but the tools that we use for the most part will not. Your TI-83 or 84 graphically will not put an open dot there, but it will when you go to your table. It will say error there on your table, and that's kind of something that people have been asking about using TI-83, 84 with the table. And graphing these things. But that's what I would do every time I type one of these in and I find the domain and I think I have the domain right. I would graph it, and then go to my table, and I would look at those critical points that I think should have been kicked out of my function. I would go to my table, and I would type in as an x value of -1, and see what it gives me back for a y value. It should say error, okay? And then I'm going to plug in 0 as x, hit enter, and it should give me back error for the y value. And that is then verification that, yeah, I'm probably good to go, all right? Or at least the two that I found so far are being verified, okay? So it's a good thing to do. Use that technology, kind of back yourself up. That's how you do one of these combination questions. Are there any? Does that help answer your question? Does that help answer your question? Yeah. Okay.
I did exactly what you said.
Parentheses?
I was reversing one value onto the other.
Okay, good. Any others on there? 4? Okay. Similar idea. All right, just new function. So we're going to go, f of x's domain is all real numbers. Okay. You plug in any x value you want to, and you're going to get an output. But what is g of x's domain? 0 to infinity. What do I include 0 or exclude it? Include it. So include infinity. Sorry, include 0, exclude infinity. And now the overlap of those two things, you kind of visualize what's going on. Let's say, let's move that a little bit. So this is, f of x, if this is my number line, f of x is doing that forever on my number line. If 0 is there, g of x is looking like that. Okay, and hopefully you see that they overlap at 0 and then to the right of that, right? So the domain, the overlap, okay, the intersection. So like if I write maybe this kind of notation, domain of f of x, subscript f of x, intersect domain of g of x. I don't know if you'd ever see it written that way, but just want to kind of show you that we're intersecting the domains. That intersection of domains would simply be 0 to infinity. Okay? And that's going to be then the domain for f plus g, f minus g, f times g, g plus f, g minus f, g times f. Okay? So let's go ahead and start adding these together. If I have f of x plus g of x, that's going to be x plus root x. Domain again, that domain. If I go f minus g, and you kind of start to see that WebAssign is tired of putting the of x on there, right? Okay, so that might be a notation that you see every once in a while. I'm getting tired of writing that, so that's why I'm going to do it. But f minus g, so that's going to be x minus root x. F times g is going to be x times root x. Okay. An equivalent way of writing that, because we should know that that's x to the first, x to the 1/2, and when you have like bases, what do you do with the exponents when you're multiplying? Add them together, so we get x to the 3/2, which is also the same thing as root 2 of x cubed. Those are all equivalent statements. Okay, that I might not have a great idea of what that looks like, but I think I have a pretty good understanding of what that looks like. Okay, just because of my background. So as we progress this course, hopefully we can start realizing what things like that might end up looking like. But again, the domain of that still that 0 to infinity. Okay. And hopefully you can verify that. You can convince yourself of that no matter what x is. If x is -5, cube it, I get -125. Can I take square root of -125? No? Okay. If x is -3, I get -27. Can I take square root of -27 and get an output? No? Okay, but if x is 0, I cube it, I get 0. Can I take square root of 0? Yeah, so I start at 0. That's the first value I'm going to get an output for. And then moving to my right, I'll still get, on the x-axis, I'll still get output values. Now f over g, okay, is going to be x divided by root x, okay? Now the domain of this is going to change, because remember, we're interested when that thing may potentially be equal to 0, right? Because we don't want to divide by 0. We can't divide by 0. So in my domain, initially, we say it starts at 0 and goes to infinity, but because of this, we've got to do a little bit of extra work, okay? And we want to think about when does that thing equal 0? And we're going to say we basically answering the question here is we want to know at what value of x can we not use in the bottom, okay? Whether you like putting that not equal to sign in there or the equal to sign, know that what you're about to find out about x, you're going to exclude that from your domain. So when, maybe you like I say, maybe you like to put 0 equal 0. When will root x be equal to 0? For what x value will root of x give you 0? 0. So that means we're going to exclude 0. Okay? So how does that change this domain? Yeah, it just changes it to a parenthesis. Okay? And people a lot of times on tests or quiz will say, well, I got the right numbers, but it's wrong because I put the wrong bracket. It's just a notation thing. You're right, it is a notation thing. But that notation means, 0 to infinity, that's an infinite number of values, right? Okay? But if I go 0 to infinity and I exclude both those, it's the same amount of values minus 1, right? Okay, so it is a different answer. So make sure that we kind of understand that. That is a huge deal to change that to a parenthesis. If I go g of f, okay, so that becomes root x over x. Okay, and its domain, again, 0 to infinity. But what can the denominator now not be? 0. That one's maybe a little bit easier to kind of evaluate because of that function. But for the same reason, we exclude 0. All right? I want to kind of stop right there with the homework for today because I do want to talk about the domains